Hello everyone, I am Prateek Kumar. So this is the first video of the series of videos which I will post subsequently, wherein I will cover the entire spectrum of fundamentals of physics. So in this video I will cover the basics. I will cover coordinate system, vectors, calculus, and then I will explain velocity and acceleration. So as you can see, coordinate system, vectors, calculus, these three are essentially heavily drawn from mathematics. And I firmly believe that if you have to do well in physics, you must understand mathematics really well, because mathematics is a language of physics. If you understand any concepts of physics with the help of these three, mathematical tools, trust me, your understanding will be very concrete, right? So let's start. Let's start. Well, a coordinate system is important because it helps us to locate the unique position of an object in space. A unique position of an object is important because then only we will be able to do any analysis on its motion, and physics is all about doing analysis on the motion of an object. So without a coordinate system, in principle, we cannot apply physics, right? So it's very important to understand coordinate system. So essentially there are many coordinate systems, but in this video we will discuss about these three coordinate systems: Cartesian coordinate system, polar coordinate system, and cylindrical polar coordinate system. In a Cartesian coordinate system, the unique position of a point of an object, which is denoted by this point P here in this diagram, is determined by three parameters: x, y, and z. So what are these? So in Cartesian coordinate system, we have three perpendicular axes denoted by x, y, and z. And the three parameters are as follows. So x is the perpendicular distance of point P from the yz plane. Y is the perpendicular distance of this object from the xz plane, and z is the perpendicular distance of this point P from the xy plane. So if we know these three values x, y, and z, we can determine its unique position. Let's move to the polar coordinate system. So here we will consider polar coordinate system in two dimension here in this particular case. So in a polar coordinate system, the unique position of an object P is determined by two parameters, r and theta. So r is basically the distance of this point P, or the object under consideration, from a reference point, a fixed reference point, and theta is the angle which this point P makes with a fixed direction, which is denoted by OX. So if we know r and theta, we can determine its unique position in two-dimensional plane. Cylindrical polar coordinate system is used in three-dimensional space. So for determining the position of this object of this point P, we need three parameters: r, theta, and z, where r is the perpendicular distance of this point P from a fixed axis, reference axis, which is denoted by OZ. Theta is the angular direction of this point P from, again, a fixed direction, which is denoted by OX, and Z is the perpendicular distance of point P from a reference plane, which is denoted by this shaded figure. Now let's understand vectors, which are again very important. So when someone asks our age, what do we say? Our age is X years. We don't say our age is X years in south direction. So age is just a number. So age is a scalar. When someone asks what is the velocity of that moving object, we say that the velocity of the moving object is 2 meters per second in the northwest direction. So the velocity has both magnitude as well as direction. So velocity is a vector. So vectors are entities which have both magnitude as well as direction, right? Now let's understand few important stuff in vectors. The first one is the law of vector addition. So let's say I have two coordinate axes, OX and OY. And in this axis, in this coordinate system, I have two vectors, AB vector and BC vector. So let's say the magnitude of AB vector is A and magnitude of BC vector is B. Then if I add AB vector and BC vector, then the resultant vector will be given by AC vector, right? So this is the law of vector addition. You know, these AB, BC and AC, they form a vector triangle, right? So AC vector is the sum of AB vector and BC vector. The magnitude of AC vector will be given by magnitude of AC square. The square of the magnitude of the AC vector will be given by A square plus B square plus 2AB cos theta. So this is the law of vector addition. Let's understand unit vectors. So let's say I have this OB vector whose magnitude is A, and let's say I define a unit vector u cap such that its magnitude is 1 and the direction is along OB. Then I can write OB vector as the A times u cap, where A is the magnitude of OB and u cap is the unit vector along OB, right? Now let's understand resolution of vector. So again, let's say I have a vector OB, and as we can see, OAB form a vector triangle. So by the law of vector addition, OB vector is given by OA vector plus AB vector. Now I can write OA vector as magnitude of OA times unit vector along OA, as I discussed earlier, and I can write AB vector as magnitude of AB times unit vector along AB. Now let's define I cap as the unit vector along OA, and j cap as the unit vector along AB, right, which is essentially OY. Then I can write OA vector as a magnitude of OA, which by trigonometry is OB cos theta times unit vector along OA, which is I cap, and I can write AB as OB sin theta j cap. So this now OB cos theta is the component of OB along x direction, and OB sin theta is the component of OB along y direction. So this is how we do the resolution of vectors along the axis. Now this is very important. We will be using this resolution concept extensively in the subsequent topics. So now we will discuss about calculus. So first we will discuss about differential calculus. So let's say in this coordinate system x, y, I have this particular graph. In this particular graph or function, let me have 2 points A and B, and let these distances be delta x and delta y respectively. So the slope of this line AB, the slope of AB will be what? It will be delta y by delta x, right? Now let's say I have a point P over here, and let this line AB move towards P. So if we gradually move towards P, we will get these lines. One line will be like this, other line will be like this. So ultimately we will reach this point P. So this line will be the tangent at point P. Now the slope of the tangent at point P will be what? At this point P, essentially this delta x will converge to 0. This delta y will also converge to 0. So the slope of this tangent at point P, the slope of tangent at point P will be what? Will be again delta y by delta x, such that delta x is converging to 0. In mathematics we write it as limit delta y by delta x such that delta x converges to 0. So this term is called dy by dx at x is equal to P. So dy by dx at x is equal to P is essentially limit delta y by delta x such that delta x tends to 0. So when I say dy by dx at x is equal to P, it means the slope of the tangent at point P, right? Another word to interpret dy by dx is the rate of change of y with respect to x. Let's start the integral calculus. So let's say again I have a function denoted by this graph. So let me take 2 points on this graph, a dash and b dash, and let's assume that a dash, b dash are very close to each other, such that the horizontal distance between them, which is dx, is very small, right? And the y value of a dash is, the y component of a dash is y, so such that a dash, c dash is y, and since b dash is very close to a dash, we'll assume that b dash, d dash is also y. So in a way, a dash, b dash, c dash, d dash, they form a rectangle. So the area of this rectangle, will be what? It will be y times dx, right? This will be the area of rectangle a dash, b dash, c dash, d dash. Now let's say I integrate this and I move my x from a to b, then essentially I will get the area of the curve, area under the curve from point A to point B, right? So integration of y dx from A to B, is essentially the area under the curve from the point A to the point P. So this is the meaning of integration. Now let us use all the concepts we discussed earlier to understand velocity and acceleration. So let us have a coordinate system xy. In that coordinate system, let there be a particle which at time t is equal to t1 is at point A, and it moves in this coordinate system such that at time t is equal to t2, it reaches point B, right? So at t is equal to t1, the position vector of this particle is denoted by this r1 vector, and at t is equal to t2, the position vector is denoted by r2 vector. So we define the average velocity. We define the average velocity as the change in displacement over the change in time interval. So in this case, the average velocity of the particle will be what? Change in displacement, which is r2 vector minus r1 vector divided by change in time interval, which is t2 minus t1, right? Now, what is r2 vector minus r1 vector? R2 vector minus r1 vector is essentially this vector, AB vector. Let me call this as delta r vector. This we discussed earlier, but this is by the law of vector addition, right? And t2 minus t1 we can write as delta t. So we can write average velocity as delta r vector divided by delta t. So this is average velocity. Now instantaneous velocity is what? Is defined as dr vector divided by dt. Now as we discussed earlier, dr vector by dt will be what? It will be limit delta r vector divided by delta t such that delta t tends to 0. So instantaneous velocity is essentially the rate of change of displacement with respect to time. So velocity is defined as dr by dt. Acceleration is defined as rate of change of velocity with respect to time. Now if you see the differential equation, if I move dt towards this side, then we will get dv is equal to a dt. And let's say if I integrate this dv from v is equal to u to v is equal to capital V, and this time dt from t is equal to 0 to t is equal to t, then we will get v minus u is equal to at, or v is equal to u plus at. This is an important relationship between velocity and acceleration. Now velocity is what? Velocity is dr by dt. So if I replace this v as dr by dt is equal to u plus at, and again if I move dt this side, then I will get dr is equal to u dt plus at dt, right? And let's say again if I integrate this from r is equal to 0 to small r, and time t is equal to 0 to t is equal to t, again here t is equal to 0 to t is equal to t, then we will get, if we solve this, we will get r is equal to ut plus half a t square. So this is another important relationship. So these two are important relationships, and if we use these two equations, we will get one more equation, which is v square minus 2u square is equal to 2 r into a. So this is the third important relationship. So thanks for watching this video. Hope you have got a basic idea of velocity, acceleration, and the basics of physics. So in the next videos, we will discuss about some subsequently advanced topics. So if you have liked the video, please subscribe to my channel. Thank you. Thanks a lot.